Hello, everyone, and welcome. Today we have an interesting presentation. We're going to see some optical illusions. And after you see this video, you're going to read a paper that I wrote that argues, that explains how our perceptions are processed in the brain. You see, most people assume that our visual system is like a camera that is capturing what is out there exactly the way it is out there. But through these optical illusions, we're going to discover that that's not the case at all. That actually the things that we perceive are converted into electrical signals that will represent our perceptions. And the interpretation of those patterns depends on what is known as top-down processes. In other words, our knowledge from the past has a lot to do with the way that we see things. And it's not just in a metaphorical way, the way that we see things as how we understand the world, but actually the way that we see them physically, the way that we perceive it. So in these optical illusions, there will be some stuff that will be right in front of you and you will not see. And there will be things that are not there, and you will see them. And it's not a trick. You know, one thing for sure that you need to understand is that nothing that I'm going to be presenting to you is a trick. As a matter of fact, you can find all these things in the internet, you can Google them, and you can try for yourself. So, and in some cases, it will be very obvious to you that you are seeing things that you know that they're not there, and you will know this, and at the same time, you will realize that you are seeing what is not there. And what is that going to tell us? I mean, this is not just for entertainment. This is to make a point. And the point that we're making here is how what we see, what we perceive, what is in our mind that we think that we have seen out there is in part what is out there and a lot what is in here, what is in our head. So how we perceive the world, it involves two things. It involves, yes, the sensorial perception, the sensory perception of what is out there in the world, but it's also the way that that perception is processed. And our brain is going to fill in the gaps. Our brain is going to help us interpret what we see out there. So if I ask you before we see all these optical illusions, if I ask you, like, where is color, right? So what, if I see something blue, is it blue because out there is blue, or is it blue because in here in my head is blue? And what we're going to see today with that particular optical illusion is that color is added in the process of processing that visual input. And of course, it has something to do with what is out there. There's a frequency of light that is that our visual system is picking up. But the actual color is added in the brain. So we're gonna demonstrate this with one of the optical illusions. So let's get started. All right. So the first thing that we have here, I mean, there is an optical illusion there. It said, you know, which one is the case? It said that we have some white crosses in a black background, and the crosses are moving, or do we have the opposite? Do we have black crosses in a white background and the crosses are moving? And of course, depending on how you shift the attention, you will see one or the other. Now, I want to call your attention to the title of this presentation, and there is a word that probably you have not seen before, most of you at least, that is the word hermeneutics. So what is hermeneutics? It's going to be in the quiz that you're going to take after you read the paper. So pay attention to this part because it's nowhere else. It's just in here. So hermeneutics is the science that studies interpretation. So let me say it again, make sure you get it. You know, it's the science that studies interpretation. Say, for example, we're looking at a text, and a text in the field of hermeneutics is anything. It could be written text, it could be visual text, right? It could be something we hear, right? So a text will be something, a sign that will be interpreted. And then how do we interpret the meaning is going to depend on many different things. So in hermeneutics, we study about biases, we study about context, we study about the history of a term, the way of comparing a text with other texts so that we can understand the meaning. We learned, for example, about the hermeneutic circle, how interpretation, understanding of a text requires both context and details, and it's a back and forth between the two and so forth. But the important thing that you need to know for your quiz is that hermeneutics is the science or the art, sometimes it's referred to as an art, that studies interpretation, all right? So the title of this presentation is Hermeneutics and Optical Illusions. So here we have our first optical illusion. So here we see, probably if you look at the crosshairs at the center, you're going to see that there is a green circle that is going around, that is rotating in a clockwise motion. Now, you will be able to examine this later on, but I would like to inform you that there is no circle, no green circle. The green circle is being added by your brain. As a matter of fact, sometimes you might see more than one green circle. They might be floating around as you, concentrate on this image. But let me tell you what's going on. There is a space. As a matter of fact, I might be able to show you this if I stop the presentation. Okay, so when we stop the presentation, you can see that what's happening is that there is a space. So this space right here is going to be moving around. So it will be a space here, then it will be a space here, then a space there. So it's just a space that is moving around. But our brain interprets this not as a space, but as a green circle. This is the first hint that there is construction going on in our brain. Our brain is adding information that is not out there. Out there, there is a space. But our perception is that there is this green circle that does not exist that is moving around. All right, let's go to the next presentation. Now this one is interesting, and here you will be able to go back and forth. Again, you can Google this and find the rotating doll. And something interesting is happening here. You can change with your mind the rotation, whether it's clockwise or counterclockwise, of this figure. There's, again, I told you at the beginning, and I'm serious about it, there's no trick here. This is actually, the figure is not rotating at all. This is a two-dimensional figure going up and down. But if you look at it, you can, with your mind, instead of rotating to the right, you can perceive the doll rotating to the left. Now, the best way to do this is by looking at the feet. So if you look at the feet, then at some point, I'm trying to do it now myself. There you go. Now I'm looking at rotating the other way. And as a matter of fact, when you do this a few times, then you can actually switch back and forth. So for me right now, is rotating counterclockwise, and now it's rotating clockwise. I assure you that the figure itself is not changing directions, that the change of direction is a perception that is processed in our brain. Okay, this is the first of a couple of slides in which we have something that is right in front of our eyes and that we might not perceive it right away. If we were in class, I would ask around, what is it that you see? Some people have done this many times, and some people will see it right away, other people will not see it, and I still have some students that after looking at it for a very long time, they cannot see it. It is a picture of a cow. Now, you might think, if you don't see the cow, you might think that this is some type of like tricky way of looking at it, that is in some weird angle that you cannot see it. This is a cow, a big head of a cow looking at you. The cow is in front of you, and the interesting thing here is that once you see the cow, you will always see it. So it's not like you will forget. So once you be able to construct in your mind what these little drawings and lines and so forth, it's actually like a picture. It's more like a picture than a drawing. So once you notice the cow, once your brain can construct the cow, then you will see the cow all the time. But it might take you a while. So I will point out some to help you out just in case. These are the ears. This is the big nose, the nose right here. This is the front of the cow, the eyes, and this is the body of the cow. It's a big cow. I'm going to move on to the next slide. Of course, you can stop the video. You can also Google it, and so that you look at it until you can see the cow. Now here we're going to do an exercise. And what I want you to do is that I want you to count the number of letter F's that you find on this sentence. So just count the F's. I'm going to give you a moment so you can count how many F's you found. So when I do this in class and I ask around, I usually get different number of answers. So I get some people to say that they found 3 F's. And there are 3 F's there, but there are more than 3. So some people would say that they found 4. And some people would say that they found 5. I wonder how many you found, but there are a total of 6 F's. Now I did this a couple of weeks ago in one of my classes, and someone found 7, which I don't know how, because there's only 6 letter F's in this in this sentence right here. I will count them for you. There's 1, 2, 3, 4, 5, and 6. There are 6 F's in this sentence. Now, the interesting thing is that imagine yourself in a court of law. Let's say that you said that you saw 3 or 4 F's, and you're being cross-examined. Do you know what the letter F looks like? Absolutely. I know letter F since I was a little kid. Do you know how to count? Yeah, of course I know how to count. So that's a problem. I mean, was this sign in front of you? Absolutely, it was in front of me. If I say I saw 3 F's, it's because there were 3 F's. Well, no, there weren't. So sometimes we can have something in front of us and still not see it, still not notice it, right? And the opposite is true as well. And here's another one. This is an old one. I just like to keep it. When you look at this figure, you see a lady, and everybody sees the lady. The question is, how old do you think the lady is? And some people will describe the lady and say, well, this is a very old lady who is dressed in like very raggedy type of clothes. It must be in her 80s, doesn't have any teeth. And some people will look at it and say, no, this is actually a very young lady, is very elegant, is wearing very nice clothes and so forth. Um, of course, when you look at it for a little bit, you might be able to see both. So you can see both the young lady and the old lady. And again, this is the point, right? How perception and the interpretation of perception can vary depending on different factors in our visual processing system. Okay, this one illustrates that, of course, this is a non-real thing. Sometimes you can see a person looking at you, and sometimes you can see a person looking sideways. Of course, that it depends on where you look, because it's a figure that is not real. So, if you are looking at if you see the person looking at you, of course, the nose is out of place. So when you see the person looking at you, basically the brain is ignoring the nose because the nose is completely out of place. When we are looking at the person looking sideways, then the eye is completely wrong, right? So now the brain is then ignoring that part and is concentrating in the other part so that you can see it sideways, right? The ear is also off when you're looking at the person sideways. So here is like two different perspectives, right? But the point is not the perspective. The point is how the brain has to ignore some of the perceptions in order to give meaning to what we are looking at. So if you describe it, this is of course a it's not real. It's not a real situation, even though it's a picture of a real person. The only way to make sense of this picture is by ignoring some parts. So notice how you can do that. How you can ignore the nose and say, okay, this is half the left side of a person that is looking at me, or ignore the ear and the eye in order to say, well, no, this is a person looking sideways. Okay, so here is the one that I told you that, I mean, if I ask you how many triangles are here, right, count the number of triangles, and I'll give you a moment to do that. How many triangles do you see? And have people come up with different answers. And actually, the answer of how many triangles are here, the answer is 0. There's no triangles. There is no figure that has 3 sides. There's some Pac-Man looking figures. They're, little pointy, 2 lines pointing in different directions, like arrowheads. But there is no triangle, because no triangle is complete. However, notice something that is very interesting, because you know that the second triangle, the white triangle, is not there. I mean, you can see that it's not there. You can see there's no lines, but you at the same time see that there is a triangle there. So now we have something that is known as cognitive dissonance. This doesn't make sense, right? So the brain is holding 2 things at the same time. It's saying, well, I'm looking at a figure that looks like a David star, a Star of David, right? Kind of an inclined Star of David that looks like an inclined Star of David. And at the same time, I can see that the other triangle is not there. But yet, I can see the Star of David. So, this is how the brain is trying to process this figure and make something make sense out of it. And this is perhaps the most interesting of all the optical illusions that we're gonna see today. So here we have a checkerboard, and there's a cylinder that is on top of it, and there's 2 squares that are marked. One is marked with the letter A, and the other one is marked with the letter B. And if I ask you to describe this, you will probably tell me that The square with the letter A is like a dark gray, and the square with the letter B is a light gray. And there's clearly, there are two different tones of grays, there are two different colors. That there's no way that letter A is, not the letter, the square where letter A is the same exact color as the square where letter B is. Now, what we're going to do is, we're going to go to another slide, and notice that now I have this little circle here that I created. And I'm going to get out of the PowerPoint so that I can show you this. So this is just a geometric figure that I did. So I just went there and color it, right? And you look at it now and you say, this is the same exact color as this, right? So again, there's no trick here. This is just the same color as this. But this is also the exact same color as this. Look at it again. So here it is that color, and it's also this color. So in fact, letter A and letter B are exactly the same color. The first time I saw this, I couldn't believe it. I actually printed this. I cut the squares out. I put a one on top of the other. And yes, they are the same color. This is incredible. Later, I thought of this other way of doing it electronically. That is a little easier, okay? So there you go. They are the same color. So what's going on? And the most interesting part of this is that even after you know what's going on, you still perceive that A and B are different colors. So remember, we had another optical illusion that I was telling you, when you see the cow, you always see the cow. So, there was a time that you didn't see it, and then there was a time when you saw it, and once you get to seeing it and you understand how it is that you create the shape of the cow, then you cannot help it. You always see the cow. Right now, if you go back to counting the letter F's, you count 6 letter F's. Now, this is different because now, even after you know, you still see that these are two very different colors. So this is one and this is the other. And they are exactly the same color. So what's going on? What's going on is that the green cylinder is creating a shade. Now, of course, this is a two-dimensional picture. This is not even a photograph. But because there is a shade there, then our brain must distinguish it. It processes the color differently. So our brain makes those two colors be different because of the perception that there is a shade. So if we bring this to one that is not shaded, so you see this, if you look at it here, you would say that all these are the same color, right? Because that's the way that we construct this. But here is clearly very different. Here is very different. But when it is right under the shade, then we can see, right, that this now has a different color. That is, but the two are the same color. So that's it. So these are our optical illusions. You have the video. Of course, you can go back and play them again. You can Google them so that you can actually play with this. I will also put the PowerPoint, and I will upload it so you can play with the PowerPoint, and you can see that there is no tricks at all in all these optical illusions. So let me tell you what is next. Next, you're going to be reading a paper that I wrote for neuroscience. So it's a little heavy-handed on the neuroscience part. Now, I took a lot of stuff out, and I left some stuff, and I added some like clarifying points, translations, I called it. But I wanted to leave it there because I want to make sure that you can perceive that there is some science behind this, that this is not just little tricks and stuff, but this is actually the way that the brain works. And the point that the paper is trying to make, and that you will be quizzed on, the point it's trying to make is how what we call a top-down process, right? There's information that is on the top of our head, right, on the frontal lobe, interaction between the frontal lobe and the parietal lobe, semantic information, the knowledge or experiences from the past, and so forth. And those inform the way that we process visual input. So the things we perceive, and this is not limited to the visual system. This is it is true for all our senses, right? So the way that we process the information that we perceive from the world out there, one part of it has to do with whatever is out there. But there is a very important part that has to do with what is inside of us, what is inside our brain. So when we have semantic knowledge that has to do with our faith experience, just like with every other experience, it informs the way that we perceive the world. It changes the way that we see things. It allows for us to see opportunities that otherwise we might miss. It allows to look at people in a different way. What do you see when you see another person? What possibilities do you see? What calling do you feel? So all those things, all those perceptions, right? They have to do in part with whatever reality you're encountering, but it also has to do with the information that is in your head, put it that way. So that's kind of the point of the paper, and the very technical part, you don't have to worry about. I'm not going to ask you about any of the fancy names. I'm not going to ask you about the neurological process or any of that. I basically going to ask you about the theological component of this. So there will be a few questions about that. And there will be a few questions about the video. So if you need to look at it again and remember, I'm going to ask you to identify the different types of optical illusions that we saw. Again, the idea of the quiz is just to make sure that you go over the material. It's not to trick you in any way. So if you go over this video, which obviously if you are listening to this part, you've done that part, and then you read the paper. You might have to read it a couple of times and then take the test. So far in the last few tests that we've done, the few quizzes that we've done, so far in the last few quizzes that we've done, the majority of you got 100. So a lot of you are doing very well. There were a few people that did not do that well, and probably what's going on there is that you did not do what you were supposed to do. So in case that you are watching this video and you don't want to read the paper and take the quiz, just want to let you know that I purposely designed that quiz so that there's absolutely no way that you can pass that quiz by just guessing the answers, or your prior knowledge will not be sufficient to perform above chance. So the only way that you can pass that quiz is if you go through the paper. So some of you might be thinking, oh, I'm not going to go through the paper because it's an open book type of quiz. So what I'm going to do is I'm going to open up the quiz, I'm going to look at the question, and then I'm going to find the answer in the paper. It's not going to work, right? So, it might work for some people that are very good at reading and comprehending very fast, but it's very unlikely that you will be able to pull it off. Anyway, the whole point is that you read the paper. So sit down. It's going to take you a couple hours. Sit down, read the paper, and once you read the paper, if there's some parts that you say, I kind of fell asleep in this part, let me try it again. Then try it again, until you are familiar with the paper, and then you will see the questions and you will be able to find the answers. So very good luck. I hope that you find this material interesting. And remember that this is due next Wednesday. All right? See you guys. Bye.